All right, here is problem 8.3.27T, which is number 7 on the homework. According to a travel website, in a certain country, workers in a certain country lead the world on vacation days, averaging 23.39 days per year. The following data show the number of paid vacation days for a random sample of 20 workers. And then it wants us to complete the question. So the first thing I'm going to do is I'm just going to export or open this data table in Excel. And then I will bring this over here. All right. Sorry. Okay. So we're going to need some information to figure out the confidence interval. So the first thing we're going to need is the alpha. And so I'm just going to put, so confidence, I always start with what I know. Our confidence is 0.95. We know that our population mean is 23.39, or at least that's the population mean that they're claiming. We know that our sample size, N, is 20. And I think that's all we know from the information given to us. So we're going to need our sample standard deviation. We're going to need our sample mean, which is X bar, right? And we're going to need our alpha. So these are all things we're going to need to be able to figure this out. So alpha is just 1 minus the confidence level. Whoops. 1 minus the confidence level. And then our sample mean, I'm just going to use the average function. And our sample standard deviation is stdev.s, because we're doing a sample, and then highlight all of the data. All right, so that's what we need to figure out the confidence interval. The last thing we'll have to do is figure out that margin of error, or the amount plus or minus the sample mean we'll need. So, or that you can just call that the interval too. It's that gap in the middle, however you want to label it. To do that, I can use confidence .t. The reason I have to use .t is because I don't know the population standard deviation. So because I don't know that, I'm going to use the sample standard deviation as an approximation for the population standard deviation. And because I'm approximating the population standard deviation, then I'm using the t rather than the normal curve. I'm using the student's t distribution because that allows for more error. Okay, it's just more spread out. So anyway, so that's why I use confidence.t. And then I do my alpha, comma, my sample standard deviation, and n. So this means that that's the, in fact, I'm going to label this interval. I think I like that name better. So now my lower confidence limit and my upper confidence limit are simply the sample mean minus the interval, and this will be the sample mean plus the interval. Once it rounded to 2 decimals, so 18.34 days to 30.76 days. Then it's going to ask us if the results validate the findings. So if somebody did it, this website says that the average is 23.39, and our data says, well, there's a 90%, 95%, sorry, confidence interval that contains 18 to 30, then we'd have to say, well, that 23 falls within there. So we'll say, since the population mean of 23.39 is contained within the 95% confidence interval, it can be said with 95% confidence that the sample does not validate. Nope, that's not right. So it must be this one. Since the population mean is contained, it can be said with 95% confidence that the sample validates the website's findings. And then it asks what assumptions we have to make about the population. And the answer is not much. The only thing we really have to assume is that the population is approximately normal, that it would follow a normal distribution. And that's it. So that is problem 8.3.27. If you need help with this or with anything else, don't be afraid to reach out.